Okay, so welcome Math2526. So last class we discussed how to estimate population's mu, a population average. Now from a sample mean, we wanted to estimate the population's mean, right? So we believe a population's mean is in such a interval. So we call this as a confidence interval. Okay. So the formula is confidence interval for mu is x bar plus or minus. So this star times sigma over radical A. So so from sample we know x bar, right? We know x bar. We know sample size A. And for the sigma, we just assume we know the sigma. So the question is how to find this z star, right? So the key question is how to find z star. So we say this z star is from z table. So we just check this like, okay, suppose like this is z table or z standard normal. And so if we, let's say, like wanted to find this percentage, let's say like 90% confidence interval. Then so this cutoff point is just this star. Okay, so we just find this cutoff point such that this interval. So here, actually, from this negative, from negative z star to positive z star, such a percentage is 90%. Okay, so once we understand this, so we can check the z table find this, right? Okay, so here this sigma, we say sigma is population's mu, the population's standard deviation. From population we have mu and sigma. So so population means for all people. So for all people we have their average, people's average, and there's standard deviation. But both of them we don't know. So here in this formula we only assume sigma is we assume this sigma is no. Assume we know this sigma equals this number, right? But we say in reality sigma is unknown. So we have this question. So if sigma is unknown, then we cannot use this formula. Then how to estimate this as mu? How to find a confidence interval for mu? So for this problem, so let's check the simplest case. So simplest case is simplest distribution, which is 1-0 distribution, right? So 1-0 distribution, simplest. Or we call this a Bernoulli distribution, right? So there's P and Q. So we know for this distribution's variance sigma square equal PQ. And sigma is PQ hat. The PQ takes square root, right? Okay, so once we have a sample, like we check, like once we have a sample, so this sample like so we can have this P hat or Q hat. So the sample is, so this population is one, we call this population 1-0 population. Like here we have population, some people say yes, some people say no, right? Some people say no, some people say yes. So we have those population. So we take a sample, so we also have 1-0. We have the, some people say, some people say yes, some people say no. So from here, we can find the percentage for say yes, the p hat, right? So from the p hat, so we also can have q hat. So q hat is 1 minus p hat, right? So from the sample, we can find the percentage. Okay, so then, for in this case, this sigma, we can use this. So p hat, q hat. So from samples p or q, we can estimate this population's variance, the standard deviation, right? Okay, so now let's consider the problem. Like in the presidential election, suppose we wanted to predict who will win the election. Okay, so like we have this question before the election, can we predict this guy will win? Or Donald Trump will win, or Biden will win? So we just do a survey. So we ask so many people. So n equal 1,000. So from this 1,000, we find 550 will vote for him. Okay, so this is a p hat equal 52%. Then q hat is 48%, right? So from here, the question is, can we have 95% confidence to predict he will win the election? So from our sample, we find this percentage is larger than 50, right? So the question is whether from here we can get a true percentage will be larger than 50. So if this is yes, true percentage is larger than 50, then we can predict he will win, right? Okay, so with 95% confidence to make a decision, we also can find 95% confidence interval. So let's try find 95% confidence interval for this p. This proportion. So we say this p is just the population's average, right? So we can use the formula. So equals, or this p hat is sample's average. So our sample is just 1-0 sample. Some people say, some people so 1, some people 0, right? So we can use this formula. We say p hat plus minus c star. Okay, let it go A. So here's sigma. But this sigma, we can use this 1-0. So we say the p hat, q hat. Okay, so the square root of a pq is sigma, right? So here we can replace sigma by this. So this star at 95%. So we know this that can be 2 or 1.96. So we can plug it in here. Let's see. So that's equal 52. So plus minus, so 1.96. And so here 1,000. and this is radical p. So this is 0.52 times 0.48. Okay. Okay. So then we just wanted to do some calculation. So let's find let's put the answer here. So equal from this to this. So here we need a calculation, right? So low bound, upper bound. So low bound. So let's say let's use Excel to do those calculations. Okay. Oh. Oh, this one not to work. Okay, so here just some calculation here. Let me say. Equal 0.52, so minus 1.96, so multiply square root 0.52 times 0.48 divided by square root of 1000. Okay, so we find the low bound is thus 0.489 and upper bound is okay, that is plus upper bound is 0.551. Okay, so this interval means the true percentage or percentage for all people will between this 489 and this. So to go back to the question, can we predict he will win? So this interval, we find this interval. So here's 0.50. 0.50. So the interval is like this, from here to here. So this means this true percentage still can be less than 50%, right? So we cannot predict. Can we predict? We say cannot, because we cannot guarantee his percentage will be clearly larger than 50. Okay. Okay. So this is for proportion actually, right? So for 1-0 distribution, for we have a simple way to estimate this sigma by p hat q hat. Okay. Okay. So now let's consider this problem. So we say for proportion, let's say we want to give a 90% confidence interval for this p, or this p is proportion for all students. Okay, so here actually we can have there's a formula. We can write it down. There's a formula. So we say conflict interval for P can be thus. So P hat plus or minus Z star. So here just sigma becomes thus. Let it call PQ. But the PQ we don't know. So we just replace PQ by P hat Q hat. Okay. Okay. So now here we plug in this formula by information in the problem. Okay. So we want to find the percentage of vegetarian. Okay. So we do it so way. We check so many people. So this is N. So we say N, right? So here N equal 100. So from this 100, are you vegetarian? We found 15 say yes. So we can find this P hat is just 15%, right? Okay. So based on this, so we can find we wanted to find this confidence interval. So here P hat is 15%. So plus minus C star. So here P, okay. So P hat Q hat P is 15. Then Q is 85, right? And N 100. Okay, so here we only need to find Z star. So let's check this Z star. So this star is here, from here to here, 90%. This is Z star. So if this 90, then outside 10, so here's 5%. So we need to check so all the way down, so it's 95%. So we need to check 9500. So we need to check 9500, right? So we need to check, okay, what is this number, or what is then we can check a cut point from the table. So this 90% is also very common used percentage. So actually, so some table already will give us this star. So I remember this star equal 1.64, 1.65, or 1.645. Okay, so let's use this 1.645. So this equal, so plus minus 1.645, so times this. So this one we just use calculator or Excel to do the calculation. 15 times 0.85 and divided by 10, actually divided by 100, square root of 100. So for confidence interval, we perform answer is the slow bound to upper bound. Okay, so this is our final answer. So after a little bit of calculation, we can have the our final answer. So this is this is confidence interval for total proportion for all. Okay, so confidence interval for P. Okay, so we say for those typical situation like a yes or no question or 1-0 population, we know how to do those confidence interval, how to do those estimation, right? So we say those P, we call this as a proportion, population proportion. Okay, so we just use this formula, right? So this sigma is the p hat, q hat, take square root. Okay, so then how about the general distribution? The data is not 1, 0 data. So data like this, x1, x2, xn, this data. So from this data, we say we can find sample means, the average. Then we want to like estimate population's variance, population standard deviation sigma, right? So here we define samples standard deviation or samples variance. So for population's variance, we use this formula. Sigma square equals this, right? So we also denote this as variance of x. So if we have the distribution, we can do the calculation. So now we do not have the population's distribution. So we only have those data or samples. So those data from sample. So for sample means that they are average. Then we say is just average, right? So we can say variance is average for those square. So here we say mu, so we replace mu by x bar. Then this x can be this one, like can be x1, x2. So this square is x1 minus x bar square. So x2 minus x bar square. So the average, so we just add them up. So divided by n. But the formula is this, divided by n minus 1. So we say, according to the definition, this is average, right? So just like x minus mu, so xi, we can divide xi minus mu is x bar, right? So those squares average, so average is just divided by n, right? But the formula is divided by n minus 1. So here we have the question, why divided by n minus 1 instead of n? So here we introduce this important notation called degree of freedom. So in statistics, the mean or average is summation then divided by degree of freedom. Okay, so we can explain why divided by n minus 1, because n minus 1 is degree of freedom for those numbers. Okay, so then let's say what is degree of freedom? So here we have another question, what is degree of freedom? So we say degree of freedom is just how many numbers can change freely. Now suppose like we have these 3 numbers like x, x1, x2, x3. So each one can change freely. So we say for those 3 numbers, degree of freedom equals 3. Okay, right? So each one degree of freedom is 1. So totally degree of freedom is 3. So now, but suppose those 3 numbers have some relationship. So like x1 plus x2 plus x3 equals 0. So these 3 numbers have some restriction or have this condition or have this relationship equation. So from here we can say if like x1 can change freely, x2 can change freely, then x3 cannot change freely, right? So x3 we also can say x3 equal negative x1 plus x2, right? So once we have x1, x2, then x3 no change at all. So we say degree of freedom for x3 is 0. Then degree of freedom for x1, x2, x3. So in this case, those three numbers, degree of freedom equal 2, right? So you understand what the degree of freedom is, right? Okay. So then we go back to, so let's check here. Okay. We go back to here, explain y divided by n minus 1. Maybe we can put it to here. So we have those numbers like x1, like x1 minus x bar, right? x2 minus x bar, okay? And xn minus x bar. So it seems we have n numbers, but this n number, like here, we say this n number like x1, x2, x3, xn. So their degree of freedom is n, because each one can change freely. So here we can understand x bar average is adding up divided by n. So what is this n? This n is degree of freedom for those numerator numbers, right? For those x1, x2, xn. Okay. So here x1 minus x bar, x2 minus x bar. Those n number we find the degree of freedom equal n minus 1. So why? So because we find add them up like this, plus add them up, this equals 0. Add them up equals 0. So we can easily to conform this, add them up equals 0, right? Because this is x1 plus x2 plus x3 plus xn minus x bar minus n x bar. So x1 plus x2 plus xn minus n x bar is 0, right? So these n numbers have this relationship. So only degree of freedom is n minus 1. Only n minus 1 number can change freely. Like this one is completely determine others, right? Okay, so this is the formula for, we say this is the sample variance. Okay, so then take square root, this is equals this. So like let's take square root, we call this a standard deviation. Okay, xi minus x bar square, so divided by n minus 1. So this is sample's standard deviation. So for population, we have populations mean, populations variance, population standard deviation. So for sample, we also have those numbers: sample mean, sample's variance, and sample's standard deviation. So the formula sample means is sample's variance, sample standard deviation. Okay. So once we have the data, we can find those things like sample mean, so sample mean, sample variance, and the sample standard deviation. Okay, so sample mean, let's say it's x bar is just average, like one add them up. So I find x bar is 5, average should be 5, right? Yeah, so this number is easy. We add them up, divide by 9, 5. So let's check samples variance. So a square so equal. So we can plug in the formula, or we can let's say, so this equal to this 1 minus, just like 1 minus 5 square, each number minus 5 square, right? So plus 2 minus 5, so actually 3 square, yeah. 2 minus 5 square plus 3 minus 5 square plus 4 minus 5 square, then plus, so 5 minus 5 square, 0, right? Then again that is 1, 6 minus 5 square, 1, 7 minus 5 square, 2 square, so 3 square, 4 square. Okay, so divide by, so divided by 8. So n here, n is 9. We have 9 numbers, but we should divide by 8. So this is samples variance. So for such a problem, we can learn, maybe easier to find. So 4 square for the 16 times 9, plus 9 plus 4 plus 1. So this is 30, right? And here also same. So just multiply 2 divided by 4. So this, so divided by, not 4, 8. So this equal, just say 30, also cancel the 2, yeah, 30 over 4, or 15 over 2. Yeah, but anyway, 15 over 2, so here just the simple calculation. No, okay, so 15 over 2 is 7.5, right? Yeah, so 7.5 is samples variance. Then this A sample standard deviation equals us. Okay. Okay, so this is today's class. So today's class we just check for popular people for proportion. We can replace sigma by this, right? P hat, Q hat. So for find a confidence interval for proportion, we can use this formula. Okay, so this is for 1-0 problem. 1-0 distribution of proportions. And so for general, so at first we introduce this samples variance, and we also introduce this degree of freedom. So in statistics, with the degree of freedom is very important. So in stats, we say average should be divided by degree of freedom, not divided by the how many numbers. We should divide by degree of freedom. Okay. So for those data, so maybe we have this like, okay. So if for, let's review for confidence interval. If sigma is null, we use this x bar plus minus z star. Okay, and sigma override equal a, right? Okay, so here sigma is null. So if sigma is unknown, we just replace this sigma by s. So sigma by s, we just replace. sigma by S. So this S is a sample standard deviation, right? So it seems we can use this formula, x bar plus minus z star, and we just simply replace the sigma by S, okay? So the question is, this formula is correct, or we can use this formula, or cannot use this formula. So for such a question, we will discuss next class. So we say the answer is sometime we can use this, sometime we cannot use this. Okay? So these things we will discuss next class. Okay? So we can stop here. I'll see you next class.